This is the video notes for Unit 6, Lesson 3, Leapfrog, a Solidify Understanding lesson. It starts off with a jump start where we have 2 points. We have A and A prime, and we need to describe the following translations, how we went from A to A prime using a translation, a reflection, a rotation, or a sequence of 2 transformations. So let's go through this jump start and kind of show how we would list each of these transformations. So the first one they want us to do is a translation. Remember that A is the preimage, A prime is the image. So A is the old and A prime is the new. So let's go ahead and track how we went from A to A prime. So it looks like we went down 4 boxes and right 4 boxes. So in order to write that in translation notation, you would see it as x plus 4, comma, y minus 4. Okay, so that's how you would write a translation from A to A prime. Now, in order to do a reflection from A to A prime, we need to identify the line of reflection. So I'm going to erase what I have here for the translation and identify a reflection that could have happened. The way that I like to find the line of reflection is I like to connect matching points. In this case, we just have A and A prime, so we'll go ahead and connect those. And the line of reflection is going to be exactly halfway in between. So right here. And it's going to have the opposite reciprocal slope. So if my slope for this line segment that goes from A to A prime is -1/1, my slope for the line of reflection is going to be +1/1. So that means I go up 1, right 1, up 1, right 1, or down 1, left 1, down 1, left 1. So this turns into our line of reflection right there. Okay, so let's go ahead and describe that. So a reflection that will carry A onto A prime is reflect across, and then that line would be y equals a slope of 1 is just 1x. So I guess I'll write that 1x and then +0. Now that could be just written as y equals x, because 1x is just x and +0 we don't really need to write. Okay, now let's describe a rotation. So I'm going to erase what I have on here for the reflection and go through the process of finding how it was rotated. So to find how much it was rotated, I need a center of rotation, I need a direction it was rotated, and a degrees. So I think I'm going to still connect A to A prime. So let's do that connection. Let's do a better line. There we go. And then I think it will be my center of rotation right there at 4, 4. Because you can see that there's a circle that goes around this center, and A to A prime is 180 degrees, either clockwise or counterclockwise, whichever direction you choose. Okay, so that will be part C. So I'll say rotate 180 degrees, and I'm not going to specify clockwise or counterclockwise because you can go either direction, but I'm going to say the center of rotation because it's not the origin, it's different. So about 4, 4. Okay. All right, let's do our last one. So we've already done some combination or composite transformations. That's just 2 more transformations. So let's try to figure out one here. And to be honest, there's lots of different answers for this sequence of 2 transformations. I'm just going to show one. So let's say the very first thing that we did was a translation down 4. So let's say that was our first step. So translate x and y minus 4. Okay. And I need to split this into 2. So that'll be my first one, just down 4. And let's say my second one was a reflection. And I'm going to put in a line of reflection halfway between this new location right here and A prime. So that's here. Let's get a straighter line like that. And then I'm going to do a reflection across there. So translate x comma y minus 4, and then reflect across the line. This line is x equals 4. Okay, so I'll add that to my description. Reflect across x equals 4. Okay, so that is one way we could do this. There are, again, many other ways that we could get from A to A prime with 2 transformations, but there's one example. Okay. All right, let's move on to our launch, explore, and discuss. So the launch has us go through and identify all the pieces we need for each type of transformation in order to accurately describe it. So the first one is, if you decide the transformation is a rotation, you will need to give. Okay, so let's go through and decide what you need to describe for a rotation. Looks like there are 3 things you'll need to describe. The very first thing you need to describe is the center of rotation. The next thing is the direction of rotation. So that's really important, clockwise or counterclockwise. And then the last thing is the measure of the angle of rotation. Okay, so 3 things are needed for a rotation. In your practice, if you have a problem where a rotation happens, make sure that you describe all 3 of those things. If you describe the transformation, if you decide the transformation is a reflection, then what you need to do is give the equation of the line of reflection. So just one thing is needed to be described for a reflection. Okay. The next is what you need to describe for a translation. So if you decide the transformation is a translation, you need to describe, basically it's like the rise and the run, that's what goes into the translation notation. So you need to describe the rise and run between the pre-image and final image points using translation notation. Okay, and just a reminder, translation notation looks like this. You have x plus or minus some number a that you would fill in, and then y plus or minus some number b, and b you would fill in. The a is the left or right, the b is the up or down. So left or right, up or down. Okay, now we're going to do an activity next that has us look at a graph where a frog is being animated in many different ways, and you need to describe how the frog goes from one image to the next and so on, using adequate description based on whatever transformation you decide. So let's look at our graph. And the first one we're going to look at is image 1 to image 2. Okay, so we need to decide how we go from this location to this location. So that's our first one. The best thing always to do with describing how you go from one image to the next is decide on one anchor point and just track that one anchor point. So for me, I'm going to track the anchor point that corresponds to his heel over here. And I like this one because it crosses the grid really well. So I'm going to track here to here. So image 1 to image 2 to me looks like a translation because he's still in the same orientation. He hasn't flipped or spun. So I'm going to just count my rise and my run. And that will let me know how to fill in my translation notation. So it looks like he goes up 7 and 5, 6, and then right 6. Okay, so I'm going to go back to the table and I'm going to say translate as the first description. And then I'm going to use the translation notation to say how much. So in the x direction, it was right 6, so I write x plus 6. And y direction, it was up 7, so y plus 7. Okay. Now the next one is image 2 to image 3. Okay, so let's go to the graph and go from image 2 to image 3. Okay, so that's going to be here to here. And I definitely see that he's upside down. So that tells me something about this transformation. It tells me that he probably did a rotation around a fixed point, and I need to decide what the fixed point is. So my anchor point right here is his heel. So I'm actually going to draw in my anchor point right here, his heel again. And for this rotation, to pinpoint the center of rotation, it's actually really good because I'm pretty sure this is a 180. Like he's right side up and then he's upside down. It's actually really good to connect my anchor point from here to here. And that kind of helps me figure out where my center rotation is. And I could actually add like another anchor point and connect those. So I'm going to just put another anchor point where his third little finger is there. And his third little finger is here. And if I connect those, do you see where it's crossing right here? Okay, that is the center of rotation. I'm going to call that point A. And it looks like he's doing 180 degree rotation about point A, which is 15, 27. So we'll need that in our description up in the table. Okay, so let's go up to the table and say it was rotated 180 degrees about point A, which is at 15, 27. Okay, and I didn't specify clockwise or counterclockwise because 180 counterclockwise and clockwise is equivalent. Okay. All right, let's do our next one. So our next one is from image 3 to image 4. So let's figure that one out. How did we go from image 3 to image 4? So from here to here. Okay, so just looking at the frogs, his head is down in image 3 and his head is to the left in image 4. So to me, that looks like another rotation. So I need to figure out the angle of rotation, the direction, and the center of rotation. So 3 things I need to figure out. So I'm going to add my anchor point, his little heel, right here. So somehow this little dot went from here to here. Where is my center of rotation? So we need to figure out a point that will give me an equal distance from that point to his heel, and then from that point to his heel in image 4, right? Because we're matching this heel here to this heel here. So somehow we go like this. Kind of looks like it's over here. So I would recommend testing different points until you find one that works. One way that I could tell that this works is, let me draw in a different color, is that if I go along the grid lines from his heel to that center point, it's like that and like that. Do you see 1, 2, 3, 4, 5, 6, 7, 8, 9? Down 9. And, well, I guess you probably should be reading it. So right 2 and up 9. And so in order to, I don't know if you remember from lesson 2, but in order to do a 90 rotation, the legs switch, right? Instead of 2 boxes horizontal, it's going to be 2 boxes vertical. So that's down here, down 2. And then in order for the 9, the leg that's 9 boxes long, to be rotated 90, it has to go from vertical to horizontal, which is right here. So that's 9. Okay, which would get us opposite reciprocal slopes, right? The slope for this line is 9 over 2. The slope for this line is negative 2 over 9. So those are opposite reciprocals. So that proves that I've chosen my center of rotation right here correctly. And I'm going to name that point B. Okay, so just play around with it. See if you can pinpoint that. You will need to be able to rotate around any point, not just the origin. And you will need to be able to locate a center of rotation that is other than the origin. So just play around with it. You can figure it out. All right, let's go ahead and fill in our information. And it looks like we're going from 3 to 4. So it looks like we're going 90 degrees clockwise. All right, so let's go up here, fill that in. So it looks like we rotated 90 degrees clockwise about point B, which was located at 19, 20. Okay. All right, let's move on to 1 to 5. All right, how do I go from 1 to 5? So 1 to 5 is definitely a reflection. Do you see he's facing the right in image 1 and the left in image 2? So, but it won't just be a reflection. I think it's a reflection and one more thing. So let's figure that out. All right, so we are going from image 1 to image 5. If I add his anchor point, which is his heel, right here. Okay, from there to there. And then let's say the very first thing I do, rather than reflect, let's say I move that anchor point just down. So it's directly across from the heel on image 5. So let's say I move it all the way down to the line y equals 5. How many boxes down is that? 1, 2, 6, 7, 8, 9, 10. So I moved it down 13. So that'll be my first move. I'll do a translation down 13. And then I need to do a reflection from this new location all the way across. So I'm going to have to split that distance to find my line of reflection, which looks like it's about here at x equals 17 is where I'm going to reflect. After I've done the translation down 13 boxes, I'll reflect across the line x equals 17. Okay, I think that's a good plan. Let's fill that in for 1 to 5. So we're going to say translate x comma y minus 13. Okay, and reflect across x equals 17. Okay, so that one's good. All right, our last one is to go from image 2 to image 4. Okay, so let's figure out that one. So 2 to 4. Let's see. So 2 to 4. So right away, I'm noticing that they're not the same orientation. There's been a rotation. So why don't we first move, using a translation, image 2 right onto image 4. I like that. Let's take this anchor point here on image 2 and literally just take it down. How many boxes is that? 7. And then right, so down 7, and then right, I think that's 19. Yeah. So that the frog's heel is right on top of the frog's heel here. And then we can just kind of lay him down, kind of just do a rotation 90 counterclockwise so that he's kind of laying on his side. Okay, I like this. So let's fill that in our table. So first what we did was we did a translation. So we're going to say translate 19 to the right, so x plus 19, comma, and then 7 down, y minus 7, and rotate. We're going to do 90 degrees counterclockwise about, we'll call this point C, point C, with coordinates 28, 18, I think that is 28, comma 18. Okay, and I think that gets us there. I'll label this point here as C. All right, let's go ahead and move on to the takeaways. All right, on the takeaway page, this is purely for you. So while working today on rigid transformations, I noticed what? So I want you to write down 3 things that you noticed to kind of help with your notes. Once you've filled in your 3 things that you've noticed, these are observations that will help you. I noticed this, I also noticed this, and I'm still wondering this. Then you are done with this lesson. Just to kind of summarize what this lesson taught. In this lesson, we identified the transformations or sequence of transformations that would carry one image onto another. We justified our claims by describing or showing the essential features of each transformation, such as the center of rotation or the line of reflection. So make sure when you go into your practice that you're very detailed, that you don't leave out any of the important essential features as you describe transformations. Okay, I wish you luck. Thank you.